So welcome back everyone. Continuing from where we left off, we talked about IP addresses, MAC addresses, port addresses, and we talked about switching and routing in computer networks, basically circuit switching, packet switching. Now we will talk about a new topic called layering. What's layering? Layering means decomposing the problem into more manageable components called layers. What's the problem we are dealing with now? We are dealing with the problem of communication. How to send data from one point to another with the most efficient way, with the least cost possible, with the latest latency, with the best quality, with all these things. This is the problem that we are studying in this course, communication, how to send and receive correctly. So why we need layering? First of all, what's layering? So layering, basically, when we mention layering, you need to think of this. We divide the whole communication protocol into layers, and we name these layers as follows: application, presentation, session, transport, network, data link, and physical. So the explanation is like this. While we are trying to communicate, to send our data, there are many functionalities involved in order to make this process efficient and successful. So the best way to be able to debug the network and learn the functionalities and make the components replaceable and to be able to make modification anytime you want without affecting the whole network is to divide these functionalities and separate them into different layers, and each layer will be responsible for certain tasks, for certain functionalities, and will be independent from each other somehow. So if you want to make modification at the application layer, you don't need to make changes at all the other lower layers. If you make changes at the application, at the physical layer, you don't need to make changes at the data link. So this is the main key concept of layering, or why we need layering. Otherwise, I would call this one layer, just one layer. It's the data you converted from the moment you produce data using your application to the moment you convert this data to electrical signal, then electromagnetic signals, and send it over the air and reverse the process. But without layering, if you were just to replace your internet connection, instead of using Wi-Fi, you want to use 2G. Yes, in your mobile phone, this is your mobile phone. Instead of using Wi-Fi, you replace it with 2G or 3G or 5G. What would happen? You would need to change all the layers, the network. It will be mess. So layering makes this make all the other layers irrelevant to the physical layer and the connection link that you used. You just continue using the same layers. So this is the importance of this. So we will be talking and discussing about these layers in details, one by one. So if you want to summarize the advantages of layering, then we can put them in these 3 points. One, it provides a more modular design. Modular design, you know, in coding, even if you want to code an app, you have to make it modular, like WordPress. If you have ever worked with WordPress, it's plugin based design. It's the core is the same, but if you want to add something, it's just about functions, and it integrates seamlessly with the database and the whole system. Easy to troubleshoot. If any problem happens, you can easily identify it, locate it, and find a solution around it. And it provides isolation in order to enable a smooth replacement of components and other functionalities within your stack layer. Now, these layers are governed by protocols, and we already mentioned before in the previous lectures that protocol is a set of rules that govern data communication. The protocols in each layer governs the activities of the data communication. So the layer architecture can be classified into 2 modules, the OSI reference model and the TCPIP model. We will be studying mainly the OSI model, but also we will compare it with the TCP/IP model and see how someone can match the layers from this model to that model. So the OSI, starting with the OSI reference model. OSI stands for what? Open System Interconnection. It's a model for understanding and designing a network, understanding and designing a network architecture that's flexible, robust, and interoperable. Developed by the International Standards for Organization, which is ISO. Everyone knows ISO or have heard about it. It's only a guideline, and hence it's referred to as the OSI reference model. It's only a guideline, which means that you don't need to stick with it when you are developing and designing and building networks. You can skip whatever you want, keep whatever you want, as long as your whole connection is successful and you are able to communicate with your end node successfully. Now, the communication stack in computer networks is open to the public and people can study it. The stack, the full stack, the communication stack of cellular networks is like secret. Only few people deal with it. What's the difference between mobile networks and cellular networks? Mobile and cellular. Computer networks, usually computers, PCs communicating with each other, and they also extended them to your mobile phone when you are using data applications. But when you are using voice over 4G or 3G or 2G, this is also network, yes? This is also a network. 2G is a network, isn't it? 3G is a network, 4G is a network. 5G, the coming 5G is a network. In the future, 6G is a network. Can we call these networks computer networks? Question, I want to make you think. Can we call these networks computer networks? Are what we are studying, the things we are studying them here, are they applicable to these networks? So what do you think? What's the difference between cellular networks like 2G, 3G, 4G, 5G and computer networks? Are they the same or different? So the short answer is they are not exactly the same. They are different, but they have similar functionalities. Cellular network and the communication stack of cellular network, when you go and study it and read it, you will not find anything called session, presentation, transport. There is nothing like this. The only two similar layers are physical and data link, or they call it MAC. The others, you don't see them existing even, which means to design a communication link or you don't need to abide by the protocol or the OSI protocol that I showed you here. Because they are different. At the end of the day, the same functionality can be named and given different names, and giving it different names can cause confusion to people and lead them to think that those two things are doing different jobs, but they are basically two names for the same thing. Mobile networks and cellular networks, they are almost these like this, because in cellular networks, the people who are working there, they are different from the people who are working in Cisco and Juniper, for example. Juniper and Cisco, most of them are computer engineers driven people. In cellular networks, like give me 3 companies that can manufacture and provide and sell cellular networks. Nokia, Ericsson, Huawei. They provide cellular networks. They sell these networks to whom? Vodafone, Turk Telecom, Turkcell, the operators basically. So the network there, the engineers working in Ericsson, Huawei, Nokia, and other companies, but I'm giving just these 3 companies, they are mostly communication-driven people. They think from just communication perspective. They focus mainly on the communication concept. Therefore, they don't exactly limit themselves with the OSI structure that's used by Cisco and Juniper and other computer network companies. So they are completely different. Not completely, I should highlight this. They have some similarities at certain layers and differences at other layers. And they don't understand each other. The computer engineer expert who's coming from Cisco and Siemens or Juniper will not be able to understand what those people are doing in cellular. And the cellular engineer expert who's coming from cellular background, mostly he will be able to understand, but not everything also happening in Cisco. So two communities isolated from each other. Nowadays, there are initiatives, there are organizations who are trying to bring these two communities together, put them together, and let them decide which principle is much better, and then let's generalize this principle to all the networks, whether cellular or computer. Because we need to understand each other. For example, a computer network guys cannot mess up with the cellular network, although it's communication network. And in the computer it's communication. Why cannot I understand or do anything there? Because they have different protocols, different words, different books, different descriptions. So when you come to this field, although it's doing the same job, but you feel you don't know anything. Why is this gap created? Because of lack of communication between the computer engineers and electrical engineers. Lack of communication created this gap. Those, they don't understand those, and those don't understand those. You understand me? So the more you talk, the more you get to know the other side, the more you get to understand him and be able to share your ideas, propose much more efficient solution than the existing ones, if we understand each other. But if we talk different languages, how are we gonna understand each other? We cannot. So this is one key problem that they are working to solve it in the future. They want mobile networks to be under the umbrella of computer networks. They want computer engineers like you to be able to understand cellular networks without the need to be a cellular network expert. So this is the key things here. The purpose of the OSI model is to show how to facilitate communication between different systems. This is the main goal. Regardless of which approach you take, it's fine. I don't care. At the end of the day, I care about being able to communicate from node A to node B successfully. Whether you follow the cellular guys or the computer guys. At the end of the day, my goal is to communicate successfully. But we have to also understand each other. Understand, the communities should understand each other so that they build networks that can be manageable, understandable, and easily configurable by both cellular guys and computer guys. So the OSI model was never fully implemented. See this statement? So it clearly states that the OSI model, as we study it now, never fully implemented, which means that sometimes they skip some parts, they merge some parts. For example, they can merge the session with the presentation layer. They can merge the transport with the network. They can merge the MAC with the physical. Which means that you don't need to literally follow the exact details of how to build a communication link. As long as this communication link, you can build it successfully, it's up to your creativity to manage things and replace things and do them efficiently.
If their implementations are different, how do they are like, they can be connected with each other, like can use the cellular network in our computers and
exactly.
In our routers, even in our routers.
Definitely. This is why I told you there are differences and there are similarities.
Like, is this a new thing or something?
The similarities are in the lower layers. What are the lower layers? Physical and MAC. This is almost like in cellular network. What's the difference between cellular network and computer network in terms of OSI structure? It's in the MAC and PHY. The applications are going to be the same. For example, in your mobile phone, you use the same application that you can use at your at your PC. But your mobile phone will be connected to 2G, 3G, but this will be connected to Wi-Fi or Ethernet. So what's the key difference here is the physical layer. You just change the physical layer. But the others are okay. And most of the if you were to ask me which are the most critical, important layers among those 7, I will tell you application, the OSI environment, the operating system environment, the application you install it on the system. Then the network layer, routing and showing you which path your packet should take so that it reaches the destination. And Phi and Mac, you can put them in one layer. You call it the physical layer. So I can come up with a new protocol, call it the application network Phi layer. That's it. The others are talking about the details. If you want to isolate this from that, if you want to put this, if you want to isolate encryption from this layer, if you want to isolate connection establishment, and so on and so forth. So let's look at the TCP/IP model here. So TCP/IP means Transmission Control Protocol, which is the most common internet protocol that's taught in universities and in training centers like Cisco. The TCP/IP protocol suite was developed prior to the OSI layer, to the OSI model. So TCP/IP was developed before. Now what's TCP/IP? Let me just show. This is the TCP/IP model and this is the OSI model. What's the difference here? Can you see what are two communities from computer networks? They understand each other, but one community says that this application presentation session, this is one layer basically. And this transport, keep it as is. And network, they were not naming it network, they were naming it internet layer. And the data link and physical call it access layer. So basically you can put any name you want. And you can merge any layers you want, as long as you can reach the goal of making two nodes communicate correctly. Which one is earlier? Which one is older? Is the TCP/IP is the older one. Which one is more recent? OSI model. Which one is taught in most schools and universities and training center? Is this one. Application presentation session transport. Separating the details of application layer into 3 more layers. Why is that? To complicate things, to make it harder to understand? You wouldn't need to do that. It's just matter of perspective. You understand me? Like the other day, I was explaining modulation in another lecture. And when you search on the internet about the word modulation, you will be confronted with the definition of a definition like this. Modulation is about one signal you want to transmit, you mix it with another signal, and it becomes modulation. You are able to transmit it over the air. But this definition is very narrow, very limited, very specific, limits your thinking, limits your creativity, and limits your understanding for modulation. And because of this, you think that modulation is something like just one specific type. While modulation in its key principle is a way of conveying data by changing properties of the sinusoidal signal that you can transmit over the air according to the incoming information that you generate from your laptop. This is generic definition. When you put things in generic framework, it pushes you, motivates you to think, to innovate, to bring new ideas, new methods, new techniques that can be much more efficient than the existing ones. And the same thing here. So don't read this as holy book. Yes, it's not Quran or here. It's just their perspective. Never ever take any book you read as a holy book. The author makes mistakes. This is very important. You can question the author. You question the one who wrote these sentences. Okay, the ones who wrote these sentences, they are not necessarily right. He is presenting things from her or his very narrow angle. And you have your own angle of view of thoughts, of thinking. We just teach students that whatever written in the books is absolutely correct and you cannot question it. You understand me? No, you should have the mentality of being able to question each and everything, as long as it's not something forbidden. You get it? Another question.
What's the difference between the UDP?
This is the difference between UDP, TCP. We already explained it here in the switching.
Right.
In the switching, this is UDP, this is TCP.
I didn't know that was it.
No, it is. It is. This, if I tell you UDP is connectionless switching, TCP is connection oriented. Which one is more sensitive to latency? Which one you can use with voice and video streaming? And this is this one, connectionless, because it doesn't require you to wait until you get connected with the internet. So UDP and TCP, they are datagram and circuit switching. So returning back here to this model, I think if I ask you about the TCP/IP model, you should have this picture in your mind. If I'm talking about OSI model, you should have this picture in your mind. You should, it's very important that you memorize these in order. Unfortunately, you need to memorize them. But nowadays, like, you don't need to memorize anything because your phone is always with you, yes? You can look always at your phone and see, check. But it's good to at least remember their order. Because if you put presentation above application, it will be wrong. So you have to memorize them in order. Application, presentation, session, transport, network, data link, and then physical. And if I tell you map them to TCP/IP, you just tell me the first 3 layers are application. This layer transport remains the same. The network, we call it internet. And the last 2 layers, we call them network access. The order of the layers is very important. So, application layer. Let's now study the functionalities, the jobs, the tasks of each layer. What's the application? According to which model? We are going to use the OSI model. So the application layer, 1, it enables the user to access the network resources. Services provided by application layer. Give me example of services: file transfer, mail, directory service, web browsing, Microsoft Teams, Skype, Zoom. All these communication devices are, the communication apps, we call them, these are applications running at the application layer. Basically, you produce them by coding, by programming them in a way that enables you to let them communicate with each other. The presentation layer, what does it do? It's concerned with the syntax and semantics of the information exchanged between 2 systems. So give me examples of services happening at this layer, presentation. Anything related to translation, encryption, compression is presentation layer. For example, if I tell you at which layer you convert your written, your normal writing into ASCII code. Presentation layer. At this layer, you convert your normal typing. When you type, you write a message to your friend, it gets converted to ASCII code at this layer, presentation. At which layer you encrypt? Encryption, presentation. Is it the only layer? No, you can also encrypt at the transport or network, or sometimes at the physical. But usually here they are putting it in the presentation. Where do you do compression? Source compression. You want to reduce of your data at the presentation layer. So these are examples of functionalities and tasks happening at this layer. Now, speaking of the session layer, what does it do? It establishes, maintains, and synchronizes the interaction among communication devices. Services provided by this layer, dialog control, and synchronization. What's synchronization? Synchronization, let's say I send my data at time X. Then how long will this data take until it reaches my receiver? Let's say X plus 10 millisecond. Then at this time exactly, my receiver should start decoding. If he starts before or after, he will lose synchronization. He will not be able to understand anything I'm talking about. Synchronization is very critical in communication, in computer networks, in all the applications related to that as well. So now you get some sense of what each layer is doing. Yes? Transport layer, what does it do? It's responsible for processing the delivery of the entire message. Services provided by this. One, port addressing. Which layer is responsible for assigning ports? Which layer? Transport layer is the one responsible for assigning this port to this application. What does it do else? It does segmentation and reassembly, connection control, end-to-end flow control, and error control. For example, if your message is received wrongly, it's the responsibility of transport layer to do some control error and make sure that the packet can be retransmitted again so that I can decode it successfully. Now, reaching to the network layer, what does it do? It's responsible for the delivery of data from the original source to the destination. Give me example happening there. Logical addressing and routing. This is what a router does. Give me a device that works at layer number 3. Network layer is layer number 3. Give me a device that works at that layer. You tell me routers. Routers work at this layer. Give me a device that works at data link layer. You tell me switches. Switches work at this layer. Give me a device that works at the physical layer. You tell me hubs work at the physical layer. Cables, wireless, the air, the medium. You get it? So this is the interface card. Data link layer, what does it do? It's responsible for the delivery of data frames from one node to another node. Services are provided by that. Framing, physical addressing, flow control, error control, and access control. Flow control, error control, access control. What are the differences between them? So let's start with access control. Access control, let's assume all the students who are taking this course want to access the Wi-Fi access network right now. So how does this happen? So each one of you will send request to send, and if the channel is empty, idle, there are no people communicating, and there is no congestion, it will reply with request to receive. You are allowed to transmit. If it's idle, no interference. So you send your packet, but when you started sending, your packet collapses with another packet, and you experience collision, and therefore you lose your data. So you back off. It gives you random window, like random time window. It tells you that please wait for this many minutes, this many seconds, so that you try again to transmit your signal. Now, who coordinates and organizes this accessing procedure? The MAC layer. Wi-Fi has random access protocol. So it's random access has low quality service level, unlike the service provided to you by 2G, 4G, or 5G. In 2G, 5G, the internet quality is much more than Wi-Fi, and usually you don't lose connection with 2G, 5G, but with Wi-Fi you always lose connection. Why? Because of collision, because of not maintaining the quality of service required by the user. So access control, basically, I have resources, time and the frequency resources that I can give you so that you can transmit your data over. The MAC layer is responsible for distributing these resources to the users according to the applications they are using. If you are using video, I should give you more time slots, more frequencies to carry the video you are producing, because the size of your video is huge, gigabyte, 2 gigabyte. But if you are using texting, I should just give you one time slot maybe and one frequency, because the size of the message you produced is not that large. This is access. This is what I mean by access control, coordinating the user. Which one should access now? How much bandwidth I should give him? How much time? How much frequency? And so on. Error control. What's error control? I send you a packet, a frame, and you receive it, but you try to decode it. You are not able, you are not successful, you are using channel coding. The packet was not decoded successfully. So what does it do? The MAC layer sends NAC message. The MAC layer is responsible for this. When the NAC message is received, the transmitter gets to know that the packet was not decoded successfully, and therefore he retransmits the packet again. The receiver again tries to decode this packet, and he was not successful. He again retransmit NAC message. So there is handshaking between the transmitter and receiver, communicating with each other, making sure that whatever I send you, it should be received within a certain duration of time. If this packet is not received within this duration of time, the receiver will automatically drop it, even if you are using packet switching. Even if you are using packet switching. There is always a limit on latency, but this limit differs from one protocol to another. Flow control. Let's say like you are using many applications on your phone, all of them running multitasking. So to solve this problem, what do? Who takes responsibility of making sure that each app gets enough applications so that it can run smoothly? MAC layer distributes. You are given 2 time slots and 2 frequencies to transmit your things over or to receive your data over. But you have 10 applications running. Different applications, messaging, video, email, file. When you open your browser, you usually have multiple tabs open. And each tab is a process, sending and receiving. Or you have also multiple applications. So who controls this? Who manages this? Who distributes this bandwidth, these resources to the applications and the users who are using the applications? So think of MAC layer as the boss, as the administrator, who manages people. Manages people according to what? According to the services they want to use. You want to use this service, I should give you this much bandwidth. Why he's managing people? Because bandwidth and time is very precious, very expensive resource. Imagine we have only, let's say, one piece of bread, and one of you is doing really physical activities, and the other is doing little activities. So the admin should distribute this cake or this piece of bread not equally, because equality here is not justice. He should distribute this according to your need. If you are doing physical activities, it means that you need more energy, more food, so I should give you more. But if you are doing things that are related to browsing, you are not exerting too much efforts, that's why I should give you little amount of food, so that we utilize this one piece of bread in the most efficient way. So equality is not justice, and this is what in computer network happening. This is a very big problem in computer and cellular network. How to distribute the resources in a justice, fair manner among users according to their needs. We call it resource management. Resource management, how to manage it effectively. Very big challenging problem. Hundreds, thousands of researchers around the world are working on this problem alone. Like part of my PhD studies was related to this as well. How to manage the resources while considering security requirements, not only throughput, reliability, latency, but also security. Because not all the applications require the same security. For example, if you are sending messages, it requires the most strict security. But if you are sending videos and voice, if I want to degrade your quality, your application quality, all what I need is to send drop a few packets, and I challenge you if you can understand the call. Yes, let's assume I'm making a call with you, and every 1 millisecond I drop a packet. Then you will not be able to receive your whole message correctly. What does this mean? This is like someone attacked you and prevented you from understanding the message. But in messages, it's gonna be, you have to deliver it fully correctly. And if you want to hack the message, you have to corrupt it whole. Yes? You can with more than one, of course. With more than, and this is the responsibility of the MAC layer. In the previous lecture, we mentioned broadcasting, multicasting, and point-to-point communication. So broadcasting is when someone alone is sending to many devices, many nodes. Like a streamer, when he's streaming applications, it's all about multicasting. One user is sending data to multiple users. TV stations, when you are watching TV, it's about one satellite is broadcasting the information to millions of people on the earth. Broadcasting. Who controls this? The MAC. The MAC decides on this. And physical addressing is very easy. We already know that it's responsible for giving an address, physical address, to each and every communicating node. So the physical layer, the most mysterious and the most difficult layer ever is what? The physical. All the magic is happening at the physical. Without the physical, we would not have any layer. We would not have any communication possible. And the magic is all happening there. But unfortunately, you don't study anything about physical layer in your whole 4 years of study as a computer engineer. Really. You don't know anything about physical layer. Physical layer, you can study it for 5 years, 10 years and don't finish it. And in your whole 4 years of study, you don't even touch it. And what's happening there and how to connect. So what's physical layer? So yeah, now all the information at the network layer, your information, you call them packets. At the application, you convert the letters to ASCII codes and then to bits. You collect the bits together, then it becomes packet. At the data link layer, it becomes frame. At the physical layer, what does it become? At the physical layer, what does it become? You have to convert them to signals. Imagine sequence of bits, packets, then frames. Then you need to convert this to signals. Then one might ask, why should I convert them to signals? The answer is simple. Without signals, you can never ever send any data over the internet or over any cable or over the air at all. And which signals? First, you convert them to electrical signals. You do some processing on them, electrical signals. 2 branches, I and Q. Real and imaginary. You use exponential functions, which are exponential functions like e to minus jwt, which is equal to cosine wt multiplied by, exponential function. When you write an exponential function like this, e to minus jwt, this is the carrier that has the frequency and time that allocates the resources, the time and the frequency to the users according to their needs. But how come this is exponential function? The exponential function here generates 2 components. These 2 components are cosine and sine. Cosine and sine. E to minus jwt, write it in terms of cosine and sine. Anybody knows how to write it in terms of cosine and sine? E to power minus jwt. How to convert it to cosine and sine? Anybody knows from math? So here at the physical layer, you need to be excellent at math, excellent at computer, excellent at communication, electromagnetic, circuit, all these to understand how things happen there. And mostly the science there was secret, confidential until 2000 and after. They were even not publishing books about how the physical layer really work. Everything related to applications, network, data, open source, available on the internet. If you search, you can find it. But on physical layer, you don't even find information. When you search how to build a network interface card, how to build modulation, from the moment you get your packet to transfer it to electrical signal, do some processing on it, and then convert it to electromagnetic signals using an antenna and send it through the air, and let the receiver to convert this, something you don't see over the air, to data bits that carries your voice and data and information and video. Magic, this is magic. How this magic is happening? So this is like confidential science was. It was monopoly, mainly restricted by companies like Ericsson, Nokia, Huawei, not shared. Even the people who study like courses in universities, they really don't know how these things are really happening in the practical world. So physical layer, see how much we are writing about it? Just a few sentences for this course, because it's not the topic of this course, but it's mystery, this layer. And if you ever want to discover the secret of networks and how things work and understand the whole things, physical layer is really one of the key layers to answer many questions you have in your mind about communication and how things happen. For example, the concept of modulation, where does it happen? Where does it happen? And why we need modulation? Imagine without the concept of modulation, nobody would ever figure out how to send his voice over a distance. How do you send your voice over a distance? There is something called modulation. You don't know now unless you study and learn and understand what modulation is. So in a nutshell, let's just show you what you are required to know about in this course regarding physical layer. It's responsible for transmitting bits over a medium, but how? It's not explained here. It also provides electrical and mechanical specification and electromagnetic propagation specification. Let's just briefly mention few little services provided by physical layer, which are not all of them listed here. First, physical characteristics of the medium. What's the channel model of the wireless medium I want to communicate over, so that I can make sure my receiver can compensate the effect of this channel and get my data right to the receiver. I know that now you are not able to relate to the technical terms here. For example, propagation channel model, equalization. What's equalization? What's a propagation model? Why should I know the model? Why the transmitter should be aware of the model? Why the receiver has to know this model? Why they have to estimate this model and guess it before they start sending data actually? What's data rate? What's bit error rate? Line configuration, representation of bits in electrical, electromagnetic, radiation patterns, RF, analog, power amplifiers, filters, antennas. All the antennas is just one section of the communication. You can take 10 courses about it on just the antenna topic. Antenna. Microwave. There is in some universities they give microwave as a course, microwave antenna as a course, power amplifier as a course, modulation as a course. Imagine just one word, one simple thing is a course, full course, and you don't talk about each and everything. And here we are compressing physical layer for you in just a few statements. So in summary, if we want to summarize the 7 layers we have talked about: application, presentation, session, transport, network, data link, and physical layer. We can say that application layer is responsible for mail services, directory services, web browsing, and so on and so forth. Application layer is deals with things related to translation, encryption, compression, and so on and so forth. Session layer deals with things related to dialog control and synchronization. Transport layer deals with port addressing, segmentation, and reassembly, connection control, flow control, and error control. Network layer deals with logical addressing and routing. Data link layer deals with framing, physical addressing, flow control, error control, and access control. Physical layer finally deals with physical characteristics of the media, representations of bit, data rate, synchronization of bits, line configuration, physical topology, transmission mode, antenna, power amplifier, equalization, modulation, waveforms, beamforming. All these are concepts under the umbrella of physical layer. Who defines the physical layer? Very like global organizations that invite all the big high companies in the world get together and discuss what should be the physical layer. Why they discuss with each other what should be the why they have to get together and discuss what should the physical layer be, in order to make sure that the devices that are produced or used by the customers here in this country can talk to the devices that are produced in other countries. You get it? We call this process standardization. Standardization is the process that through which we make sure that devices, manufactured networks can work in any country seamlessly and while maintaining compatibility between the devices with each other, with the network, and network with the devices. So these are important concepts, important issues that are related to building successful communication links between node A to node B. So with this, we conclude our lecture for today, and we continue discussing and talking several other topics in the coming lectures as well. So thank you everybody for sticking around. Take care, stay blessed, and see you next lecture.